This exercise, how to draw the orthographic projection of a particular point, that has been described in the last class, and I have shown you how to draw it in your paper. The first question in this exercise has been completed in that class. Now, actually there are 9 different conditions that we described in the last session and last session. All those things is included in this particular question. And now let me show how to draw it. I am not drawing it, but an animated picture of an animated slide is there, so you can get an idea how these things will look. Because I have already shown you how to draw it, it will be easy for you to complete this drawing. So, as we said, the entire drawing is to be in a single XY line if possible. If it is not possible, then you can use multiple XY lines. Anyway, no need to draw 9 different XY lines to draw all these things. So now the XY line is here. It should be a thick line, dark line. Then the first question, that is the line is 20 millimeter above HP and 15 millimeters in front of VP. That is the question. So first we draw a vertical line which is perpendicular to XY line. XY line we consider it to be a horizontal line. So any line which is perpendicular to XY line will be a vertical line. So we draw a vertical line, and on that particular line above the XY line we mark a distance which is equal to the distance of the point from HP. Distance of the point from HP is marked above the XY line on this particular line which is drawn perpendicular to this XY line. This particular line which is perpendicular to the XY line is known as the projector line, which we have already discussed. So on the XY line you mark a point, and A dash, there should not be any circle where you mark that particular distance. It should be only a single point which represents that one. No, don't put a cross there. Mostly what we have seen is students put a circle there, create a very small circle. Don't create a very small circle, or don't create a cross there. Only thing is you have to put a small point there, so that we will be able to identify that where this particular point falls. The A dash, the point A dash falls on what point. Because in most of the cases the projector will be of a larger length than required. So you can draw it to a larger length, then only the distance that is required can be measured and marked. So A dash is marked. Then likewise 15 millimeters below XY line. Since the point is 15 millimeters in front of VP, so this particular point is in front of VP as well as above HP, which falls in first quadrant. You know, in first quadrant the XY line, sorry, the front view falls above the XY line and the top view below the XY line. So below the XY line means how much distance the particular point is in front of VP. That particular distance is marked in the top view. So that particular top view, that is marked here. So this is point A. Now what we have to do is we have to draw the extension lines as well as the dimension lines, then mark the dimension. So both the extension lines and both the dimension lines with the arrows. The dimension lines are obviously with the arrows. So all these 4 lines, and then mark the dimensions. So this is the answer for the first question in the exercise. Now coming to the second question. In that case, it is 20 millimeter in front of 20 millimeter above HP and 15 millimeters behind VP, if I remember it right. So it is the A dash, the point A dash should be, sorry, not in this case, the point is B. The point B dash is 20 millimeter above the XY line, and since the point B is behind the VP, means when we rotate the horizontal plane 90 degree clockwise in such a way that whatever is behind the HP, whatever is on HP which is behind VP, whatever is on HP which is behind VP, comes above the XY line. So likewise we rotate it. So here is B. So the distance of B dash will be 20 millimeter and from XY line, and the distance of B from XY line should be equal to 15 millimeter. So this is the case of the second condition. So in this case, what the one thing that you have to notice that the line, this line which marks the 15 millimeter, that should be inside the 20 millimeter, so that the dimension lines should not cross each other as far as possible. Whenever it is possible, the dimension lines should not cross each other. But in some cases, it is not possible. In some cases, you have to draw it in such a way that the dimension lines cross. There is no other options. But here there is an option, so that the smaller dimension, if we draw the smaller dimension inside, then obviously we will be able to draw in such a way that the dimension lines doesn't cross each other. So so this is the second line, second answer to the second question. Now we move on to the third one. In the third one, it is 20 millimeter below HP and I don't like 20 millimeters below HP and 20 millimeter in front of VP. 20 millimeter below HP and the point C. Point C is 20 millimeter in front of HP and 15 millimeters in front of, sorry, it has a small mistake. 20 millimeter, point C is 20 millimeters below HP, 20 millimeters below HP and 15 millimeters in front of VP. In front of VP means the top view is below the XY. Below HP means the front view is below XY. So in this case, both the points, both the points C dash as well as C, the front view as well as the top view, falls below the XY line. So here you can draw the vertical line. No need to draw the vertical line, that is the projector line above the XY line in this case, because we know since the point is in the fourth quadrant, both the views will fall below the XY line. So that we know when we draw the projector, only that we have to draw the projector below the XY line only. So here C as well as C dash is marked. C is 15 millimeters below the XY line and C dash is 20 millimeters below the XY line. Now mark the distances also. The dimensions, the distances are marked in such a way that the dimension lines doesn't cross each other. So 20 as well as 15, these are also marked. Now we move on to the fourth question, in which the point is in third quadrant. That is, the point C is 15 millimeters behind VP and 20 millimeters below the HP. 20 millimeters below HP and 15 millimeters behind VP. So that is in the third quadrant. In third quadrant, if the point is in third quadrant, we know that that front view is below the XY line and top view is above the XY line. So we draw 20 millimeters, or we mark the 20 millimeters below the XY line and mark the point D dash, that is the front view, and 15 millimeters above the XY line and mark the point B, that is the top view. Now we mark the dimensions also, that is the distances, 20 millimeter as well as 15 millimeter. So that is the fourth one. And now coming to the fifth one, the point E is in HP and 15 millimeters in front of VP. The point E is in HP and 15 millimeters in front of VP. In HP means the front view is in XY line. In HP means the front view is in XY line itself. So E dash is already marked. Then from that point we draw a projector line, And we know that since it is in HP and 15 millimeters in front of VP, the top view should be below the XY line. When the point is in front of VP, the top view should be in front of the XY line, I mean below the XY line. So we draw the projector to below the XY line only. So this point is point E. Now we mark the distance. Only one distance is to be marked here, since the point E dash is in XY line, the distance from XY line is 0, or the distance of the point E from HP is 0. So we cannot mark that particular distance. So that is only 15 millimeter is to be marked. Now the next one, here the point F dash, again the point F is in HP and 15 millimeters behind VP. 15 millimeters behind VP. In HP means front view is in XY line, and behind VP means the top view is above the XY line. So that is it. So F dash and F, then the dimensions is marked. Now the next condition, where the point is in VP, the point G is in VP and 15 millimeters above HP. Point G is in VP means the top view is in XY line. Point in VP means the top view is in XY line. So that is there. Then it is 15 millimeters above HP. So that is the front view will be 15 millimeters above the XY line. So that is this condition. Now the point is in the point H, which is in again in VP. So the top view is in XY line itself, and the point is below HP. So below HP is below the XY line. The front view should be below the XY line, and 15 millimeters below XY means, below HP means 15 millimeters below the XY line. So this is the 8th condition. And in the 9th condition, that is the point I, which is both in HP as well as VP. So in HP as well as in VP means both the front view as well as the top view should be on the XY line. So I, that is the 9th condition, I dash as well as I will be on the same point. I dash as well as I will be the same point. So this is the drawing that you have to draw in this particular exercise. Either you can draw it in the same XY line if possible, otherwise you can split it into two.
Sir, one doubt.
Yeah, sure.
Sir, on HP in front of VP എന്ന് പറയുമ്പോൾ ഫസ്റ്റ് ക്വാഡ്രന്റിലും ഫോർത്ത് ക്വാഡ്രന്റ് വരാൻ പാടില്ലേ?
ഫസ്റ്റ് ക്വാഡ്രന്റ് ഓർ ഫോർത്ത് ക്വാഡ്രന്റ് ആണ് വരുന്നത്.
വരുന്നത്. ഇത് വരയ്ക്കുമ്പോൾ എങ്ങനെ മനസ്സിലാവും?
അത് ഓൺ HP എന്ന് പറയുമ്പോൾ ഫ്രണ്ട് XY ലൈനിൽ തന്നെയല്ലേ?
Okay, അതങ്ങനെയല്ലേ?
XY line actually XY line belongs to both the first quadrant as well as fourth quadrant. അങ്ങനെയല്ലേ വരുന്നത്? അപ്പൊ ആ XY line തന്നെ ആയിരിക്കും പോയിന്റ് E dash ഫ്രണ്ട് വ്യൂ നമുക്ക് വരുന്നത്.
ഓക്കെ ഓക്കെ.
ടോപ്പ് വ്യൂ മാത്രം ഡിഫറെന്റ് ആയിരിക്കും, കാരണം ടോപ്പ് വ്യൂ എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് നോട്ട് ഇൻ VP. സോറി, യെസ്, ഇറ്റ് ഈസ് നോട്ട് ഇൻ VP, ഇറ്റ് ഈസ് ഇൻ ഫ്രണ്ട് ഓഫ് VP. ഓക്കെ, അപ്പൊ അത് ഒബ്വിയസ്ലി ഇറ്റ് ഷുഡ് ബി ബിലോ XY ലൈൻ ആയിരിക്കണ്ടേ?
ഓക്കെ ഓക്കെ. ടോപ്പ് വ്യൂ താഴെ വന്നു. ഓക്കെ, അങ്ങനെയല്ലേ? അങ്ങനെ തന്നെ. ഓക്കെ, താങ്ക് യു സർ.
Yeah. Now, in any of these cases, we have drawn a side view. Then how to get the side view also? One example on how to draw the side view is also given. So that is another question. We just note down this question. That is draw the front view, top view, and the left side view of the point A, which is 25 millimeter above HP and 20 millimeter in front of VP. So the distance from the profile plane is not given, so we can assume any distance from the profile plane. So in this case, we have to draw the front view, top view, as well as the left side view. The procedure for drawing the right side view is similar, but in the opposite direction. It will be in the opposite direction depending on in which quadrant this particular point falls. In this case, the point A is 25 millimeter above HP and 20 millimeter in front of VP. That is, the point is in the first quadrant. So in most of our drawings, whenever we have to draw the side view, it will be in first angle projection. That is, the point will be in the first quadrant, or the object will be in the first quadrant. So, and in most of the cases, we draw the left-hand side view also, left side view, not the right side view. We doesn't bother much about the right side view unless it is specifically mentioned that you have to draw the right side view. So mark down the question. Draw the front view, top view, and the left side view of the point A, which is 25 millimeter above HP and 20 millimeter in front of VP. So here also we can see it in three-dimensional representation, how it is represented. This particular point can be represented in 3 dimensions and how it can be converted to 2 dimensions. So this is our VP. So corresponding to this particular VP, this VP is in 3 dimensions, the left side, this is in 3D, this is in 3D, and this is in 2D. So the left side it is 3D and the right side it is 2D. So in 3D VP is represented. Likewise in 2D also we have represented the VP. Now here it is the HP, and here the HP. When it becomes in 2D, the HP becomes below the VP. So this is HP, and now here is the profile plane. And in 2D, the profile plane will be lying towards the right of the vertical plane. So this is the profile plane. So this is the same arrangement that we have seen in the first angle projection. So this is the same 2-dimensional arrangement of the 3 planes. Now, this line is the XY line, that is the line that is the line of intersection of VP as well as HP. And that particular line actually it can be extended to the line of intersection of profile plane and HP also, because from this line, so see this line is here up to here it is the XY line, our actual XY line, but this line is going straight, it is the straight line. So this line is similar to the XY line itself. So this portion as well as this portion, these 2 portions, this is the same as this line. That particular distance, 2 lines are same as this line. This is disjoint, or this is actually we have to cut it there. We have to separate it there so that the profile plane can be in the plane of VP. So that is why these 2 lines, these 2 edges of these rectangles, or these 2 edges of these planes are same. So in XY line, this entire line can be marked as XY line. That is the line separating VP as well as HP, and then the line separating profile plane as well as the HP, the horizontal plane. That entire line can be represented as XY line. And now the line that separates the vertical plane from the profile plane, that is this line. This line is actually X1, Y1 line, and that line actually extends to here, this point. That is actually this portion which is marked as Y1. It is part of 2 different lines. That is 2 different perpendicular lines in 2-dimensional representation. When we represent it in 2 dimension, this particular portion which is in 3 dimension, which is marked as Y1, that portion, that is part of 2 different lines in the 2-dimensional representation. In 2-dimensional representation, the X1, Y1 line, it separates the vertical plane from the profile plane. So XY line actually separates the vertical plane from horizontal plane, and X1, Y1 line separates the vertical plane from profile plane, and the part of XY line as well as X1, Y1 line, half of that will be a repetition of the repetition of the line which separates the profile plane from horizontal plane. That is the line of intersection of the profile plane and horizontal plane, HP. It is actually divided into two, and this particular division is constitutes half of x1 y1 line as well as half of xy line. So this line, this part of this line as well as this part of this line, they are the same. They are equal. They should be equal. So now here is our point A. We consider a point A, because obviously, as we mentioned in the question, it should be 25 millimeter above HP and 20 millimeter in front of VP. And distance from the profile plane is not specifically mentioned, so we can consider it to be any length or any distance. So this is the direction in which we look to get the front view. And a ray of light, okay, that ray of light is very feeble. So here is a ray of light which passes through A and perpendicular to the VP, so that we will get the front view. So A dash is obtained here. Now, in order to get the top view, we look from here and we obtain the top view here, that is point A. Now, in order to get the left side view, we move to the left and then look from there. Look from there, and then we obtain the left side view on the profile plane, A double dash. Now, these are the three views, A dash, A, and A double dash. Now, we know how to draw A dash as well as A with respect to the XY line. And in order to do that, what you do is the A dash is from point A dash, we draw a vertical line, or we draw a line which is perpendicular to the XY line, and that particular line is marked in the two-dimensional XY, and hence A dash is marked. And then point A is, or from point A, we draw another line which is perpendicular to the XY line, and likewise the same line is drawn in two-dimension also. So here we obtain A. So this much is clear. There is no doubts as for now. Now, what we have to do is we have to repeat this procedure considering A double dash also. Considering A double dash also. When we considered A dash as well as A, see here actually these four lines actually constitutes a rectangle. These four lines actually constitutes a rectangle in the 3 dimension. So likewise, we can consider a rectangle here also. Considering A dash and A double dash, we can create a rectangle. Considering A dash, this point as well as A double dash, then A, we can get a, see this line. As well as if we join A dash, sorry, we draw a line passing through A dash and perpendicular to our x1 y1 line, passing through A dash and perpendicular to our x1 line y1 line, and similarly we draw a line which is perpendicular to A double dash and perpendicular to x1 y1 line. So we draw like this. So this line A dash, from A dash we draw a line which is perpendicular to x1 y1 line, and it is extended, and this distance should be equal to this distance. This distance is equal to this distance. That is, the distance of the point A from VP is equal to this distance. That is this distance, A dash A. The same distance is here also. Since this forms a rectangle, as I said, this forms a rectangle. So this distance as well as this distance should be equal. This distance is to be replaced here or to be drawn here. So this distance as well as this distance should be equal. This distance as well as this distance should be equal. So this is the condition. So now we can draw, considering with the A dash as well as A double dash, we have drawn this rectangle, and likewise with the A as well as A dash, considering the top view as well as side view, we can consider another rectangle here also. So that rectangle will be like this. So this rectangle, from A we draw a line which is perpendicular to the x1 y1 line, and from A dash, A double dash, we draw another line which is again perpendicular to the x1, y1 line to the opposite direction. Actually, x1, y1 line is, here is an x1, y1 line, and here also it is an x1, y1 line. So this x1, y1 line is part of xy line also. This line is part of the xy line also. So if we consider this part to be x1, y1, this part to be x1, y1, and this part to be xy, in the case of our left side view. So that can also be done. Now what we do is, this line we can simply draw without no confusion. We can draw a line which is perpendicular to the x1, y1 line and passing through A. So this line. Now, from where we have to draw this line? Actually, this point we have already got, no problem. But if we doesn't have this particular point, in that case, or we doesn't know this particular distance, in some cases we might not be knowing this particular distance. In that case, or it might have been taken arbitrarily. Or in some solids, if we draw some solid figures, only distance from one point to the VP will be given. So the distance of the other corners from VP we doesn't know. So in that case, how to obtain this particular point, the side view? That is the condition. So in that case, what we have to do is, this distance in the two-dimensional drawing has to be repeated here. Here also that distance is to be repeated. So since this distance is equal to this distance, and here that distance can have to be reproduced. How that distance can be reproduced? There are actually multiple methods. One of the method is by drawing a straight line which makes an angle of 45 degrees with this line, with this vertical line. A line which makes an angle of 45 degrees with this vertical line, and it is inclined towards the upper side. That will give you the same distance, like this. So this is an isosceles triangle in which this side should be equal to this side, since this angle is 45 degrees. This angle is 45 degrees. So that if this is 45 degrees, this angle should be equal to this angle. Since this is already 90 degrees, this angle is already 90 degrees. So if this is 45 degrees, this angle should also be 45 degrees. So if these two angles are equal, this side should be equal to this side. That is one way of creating it. Another way is by drawing an arc, by drawing a circular arc with this point as center and this distance as radius. This point will be our center and this distance will be our radius. By drawing a circular arc, we obtain the same point. So any of these methods, you don't have to draw both these lines. You have to draw only one of this line, either this 45 degree line or this line. And now from this point is now at a distance of equal to this distance from the x1, y1 line. And from this point we draw a vertical line. And the point of intersection of this line as well as this line, this should be equal to a double dash. So this is our a double dash. So in order to get the side view, what we have to do is we have to draw a horizontal line which is perpendicular to the x1, y1 line through a dash, that is through the front view, and we have to draw a horizontal line from A to meet the x1, y1 line, and from that point either draw a 45 degree line so that it meets the xy line, or draw an arc with the center as the point of intersection of x1, y1 and xy line, and the radius as this distance, and thus we obtain this point, and from this point draw a vertical line, and the line of the point of intersection of this vertical line as well as the horizontal line which is drawn through a dash will give you the side view. So this is how the side view is obtained. So now this will be the side view, what we will be seeing. The 45 degree you don't have to mark it, I just marked it for your reference. So first what you have to draw is you have to draw the xy line which is horizontal, and then In most of the cases, what we do is we then doesn't draw the x1, y1 line. We draw the x1, y1 line only after drawing the front view as well as the top view. Then we draw the front view as well as the top view, which is simple. You already know how to draw it. And then from A dash, we draw a horizontal line. From A dash, we draw a horizontal line. Then from A, again, we draw a horizontal line to intersect with the x1, y1 line. And from that particular point, we draw a 45-degree line or an arc to intersect with the xy line. And from the point on xy line, we draw a vertical line to intersect with the line drawn through A dash. And this particular point, the point of intersection of these two lines will be the point A double dash.
Sir, x1, y1 line assumption alle?
x1, y1 it is the line of intersection of the VP as well as PP, the profile. It can be drawn at any distance. The distance is not given.
Okay.
So A dash x1, y1 anywhere you can draw. But close, not too close as well as not too distant. Distance close 10 to 20 millimeter, like 20 to 30 millimeter, range it will be look nice.